In this video, I will show you how to do truth trees in the propositional logic software. So I'm in chapter 11, and I'm going to do exercise 9. So as with the truth tables, right, you first want to go to the symbolizations page so that you can check your symbolization before you do your truth tree. Because if you do a truth tree, but your symbolization isn't correct, then your truth tree won't be correct. Okay, so exercise 9 says, the bird doing the bluebird call is either a bluebird or it is a mockingbird imitating a bluebird. If it is a bluebird, then bluebirds are indigenous to these parts. And if it is a mockingbird imitating a bluebird, then bluebirds are indigenous. Presumably because where else would they have learned the call, right? That's not part of the statement, but so it follows that bluebirds are indigenous. So that it follows that, that's the conclusion. So let's do the conclusion first. So bluebirds are indigenous is I, capital I. Okay, so let's do premise 1. So the bird during a bluebird call is either a bluebird or it is a mockingbird imitating a bluebird. So that's B for the bird doing the bluebird call is a bluebird. And then a wedge. Or M, it is a mockingbird imitating a bluebird. Okay. So the next is, if it is a bluebird, then bluebirds are indigenous to these parts. And if it is a mockingbird imitating a bluebird, then bluebirds are indigenous. So we have two conditionals joined with a conjunction. Oops. I'm not sure how I got there. Let's just go up. Okay. Okay, so the first one is, if it is a bluebird, then bluebirds are indigenous to these parts. So that's B, arrow, I, and then close parenthesis. And so it says I'm wrong, but that's because I'm not done. So I want an ampersand. And so now if it's a mockingbird imitating a bluebird, so that's M, then bluebirds are indigenous. So I, and then close parenthesis. Oh, I somehow got on the wrong thing. I think I keep hitting the enter when I don't mean to. It's right next to the shift key. Okay, so now I want to click the button that just appeared that says 2 truth trees. And so it will take me to the truth tree page with my truth tree already started for me, with all the premises filled in, premises and conclusion filled in on the appropriate sides. So it says left click on the red question mark to decompose the formula indicated by the yellow arrow. So if I click on this red question mark here, it will decompose premise 2, because that's what's indicated with the yellow arrow. Click it again to change the rule being applied. So basically what you're going to have to do is you're going to have to kind of cycle through the various rules until you find the right one for this particular statement. It says use the tab or arrow keys to move the yellow arrow. So so it wants me to start with premise 2, but suppose I say, I don't think that's a good idea. I want to start with premise 1. Then the idea is I can, it says use the tab or arrow keys. The tab is just moving there. Oh, maybe because I'm in here. Right, because I'm in this window. Okay. All right. So let's give that a try. So it says I can use the tab key. So see, and I could, So the conclusion is just a simple statement. So I'm not going to be doing anything with that conclusion. It just sits there. So that's why I can't tab over to there. But I'm going to follow its suggestion. I'm going to start with premise 2. And I'm going to do that because for 2 reasons. One, the software really helps you. It helps you make smart choices. So if the software is telling you to start with premise 2, it's probably a good idea. And in this case, it definitely is, because premise 2, its main connector is the ampersand, and ampersand left does not branch, right? Because the only way a conjunction is true, because this is on the true side, is if both parts are true. So this is I want to do this so that both of those formulas are on the true side of the tree. Whereas if I did premise 1, well, that's true. A disjunction is true when either of its disjuncts are true. So it's going to branch because I have to explore both of those possibilities. Okay, so I'm going to click on this. And so the first one that I click on happens to be the one I want, but suppose it wasn't. I can keep clicking on it. And you see how it cycles through the various options. But as it turns out, so it's always going to give them to you in this set order. So it just happened to be the case. It didn't do it because the software is like really smart and really super helpful and just does the right one first. No, it just happened to be, it always does conjunction right first. So that just happened to be the one that we want. So now it suggests that we do B arrow I. So sure, I mean, everything here is going to branch. So it's actually giving me 2 options. So I don't know what it, so it actually went, I'm not sure why it did that. But okay, it's fine. It was really arbitrary which of those I did first. So that's not right? Because that's if it was B ampersand M. So I need to keep going. So what I want is, I want it to branch, and then I want both B and M to be on the true side of the branch. So not that, not that. There we go. That's what I'm looking for. Okay, so now it wants me to do B arrow I. So I'm going to do that. Why not? So again, I want this to branch, but this time I want the B to be on the false side and I to be on the true side, because a conditional is true if either its consequent is true or its conclusion, its antecedent is false. So I'm going to keep going until I get the right one. Not yet. There we go. And notice how it decomposed it on every open branch. That's really important. And that's something that you have to do, but the software is going to help you do it. It's going to basically make you do that. Okay, so now we want to see if we can close anything off. We probably should have looked at that before we did the last 2 premises, but it wouldn't have made a difference. We should definitely look at it now. So here we have B on the false side and B on the true side on the same branch. So that closes. So we're going to click it. I did not mean to decompose it. So I can hit the undo button. What I wanted to do was click. No. Oh, I think I know what I need to do. I need to right click. Yes. So I right click, or in this case on my daughter's computer, since I'm not using a mouse, I'm using a pad, it's control and then click. So it's the same idea. I click once for a star, which is what I want in this case, because that's what marks it as closed. But if I click it, oh, I thought there was a way I could mark it explicitly open, but I'm not getting that option. Maybe because I'm not done. So I either, yeah, it's because I'm not done. I guess, and it won't let me make mistakes, right? You could totally make that mistake on your own, but it won't let me make mistakes. So that's helpful. So I wanted to mark it closed, so I did. Okay, so now how about this I? Well, we've got an I on the true side of the tree, and then if we follow up, oh, by the way, you see these scissors that appear? If I click on this, it will delete everything below the scissors. So if you like mess up a whole bunch on your tree, you can you could hit the undo button a bunch of times to get back there, but you can also sometimes just shortcut it. But anyway, I've got an I on the fault side, so this is going to close too. No, I thought I was right clicking. Let's try again. Okay, Control, click. What? Sorry, user error. Okay, well, I've gone too far now. I have to do B arrow I again. I went back too far. So that's where I wanted it. There we go. So I want to close both of these off. Okay. Now, how about this one? So we've got a B on the false side. We've got an M on the true side. But if we look up the branch, there's no B and there's no M anywhere. So that doesn't close. How about this I? Yeah, again, we have an I on the true side and an I on the false side. So that is going to close. So we're left with just one open branch, which is really sweet. That's what we want because it makes our trees much simpler. Okay, so we're already decomposing M double arrow I. So I want to just click, cycle through till I get the right one. And there I am. Okay, so now we have to check these. So we have an M on the false side and an M on the true side. So this is going to close. And here we have an I on the true side and an I on the false side. So that's going to close. So I can click on it. Okay, I guess I just leave it open. I thought there was a way to explicitly mark it open, but I guess not in the software. So that's just how it works. The important thing is the question mark is gone. Sorry, it's been a little while since I've used this software. But I want to mark it with a star. But let's suppose I get it wrong. Let's suppose I think that should be open. Well, I can check it. So I click this check truth tree. And it says, aha, this open branch should be closed. So that's very helpful. So now, sorry. Okay, well, how do I? Okay, there we go. So now when I check it, it says, congratulations, you have correctly completed your truth tree. What does it demonstrate? And so if I said validity, it would give me that error message saying, no, this is actually invalid because every branch closes. So I'm just going to say it shows invalidity. Come on. Oh, wait, never mind. Sorry. They all close, so that shows validity. Oh, that's embarrassing. I'd like to pretend I did that on purpose, but I didn't. I just said the wrong thing. So that's how you do truth trees. Maybe let's try to mess up some more. Let's see if we can mess up. Let's just kind of show what happens when we mess up a bit more. So I'm going to go back and I'm going to do some things wrong. So let's do M arrow I first. And we'll say, yes, it goes like that. And suppose I say, oh, look. So suppose I used the wrong rule. And I thought, M arrow I, well, that's true when both are true. For some reason, I thought that. And then I would think that it has closed. So I would say, it's closed. And I didn't have to do all of the premises. Isn't that sweet? And by the way, that is entirely possible. So had I done M arrow I correctly, this would be absolutely correct. The tree would be closed. I would be done, even though I had not decomposed every formula. So you just need to do it until it closes. But if I check this, it's going to say at least one branch uses an incorrect rule to decompose a formula. So it doesn't tell me exactly where I messed up, but it kind of gives me a clue. I mean, right, this red X is my clue. So it doesn't tell me specifically, but it kind of does. Okay, so let's try that again. So let's say I think it's this. Now I think, whoops. Sometimes it just wants to just do things. All right, we're doing B or M. So let's say I think it's that. And now I'm going to do B arrow I. And so let's say I think it's that. So let's say this closes. Oh, stop that. It's a little too sensitive. Okay, and then this would close. And this would close. And let's just say I think this closes. I'm wrong, but let's say I thought that. What kind of error message does it give us? So it says at least one branch uses an incorrect rule to decompose a formula. So it basically tells me snip it where that X is, because that's where you went wrong. I mean, as it turns out, I went wrong on both of those formulas, right? Both on B wedge M and also on the B arrow I. But even if I hadn't, right, I would need to go back to that B wedge M to that where I did premise 1, because everything downstream of it is just a mess. So I just need to start over at that point. Okay, so that gives you an idea of some of the errors that you can make and ways that the software kind of helps you figure out what those errors were and then fix them.